We're back. This is Unit 7, Section 2. We are about to start this bottom one right here. So we have a square root of x, and then the transformation right here, it's 1/2. That means vertical shrink by 1/2. So when the number's in the front, that's vertical. It's 1/2, therefore it's shrink. 1/2 is between 0 and 1, so that's why it's shrink. Now this negative right here indicates reflection over the y because the negative is in the front. If the negative was on the outside, then it would be reflection over the x. But because it's inside the radical, that's reflection over the y. Okay? And then the +2, that's easy, that's up to. And I feel like the easiest, and then you know it's going to start at 0, 2, right there, and it's going to go that way because it's reflected over the y. And the easiest way to know where the next point is just by plugging in a number right there to substitute for x. I chose -4 because I know 4 is a perfect square. So 1/2, -4, two negatives make a positive. That's why that 4 is positive. +2, square root of 4 is 2. 1/2 times 2 is 1. 1 plus 2 is 3. That's why that point right there is -4, 3. Boom, right there. So then the domain is from -infinity all the way up to 0, and that's inclusive. That's why we have a bracket there. And then the range starts at 2 and goes all the way up toward +infinity. We don't have x-intercept, but we do have the y-intercept, and the y-intercept is right there at 0, 2. One more right here on this page. So I have f of x, and I know this is cube root because I know how to go back and forth between the rational exponent and the radical. So the numerator is going to be your exponent right there, and then the denominator is going to be your index. So cube root of x, that's the parent function. And then we just need to determine the transformation. So -1, it went right 1, and -3, down 3. So it's going to start right there at 1, -3. And then it follows the parent function because there's no vertical stretch or compression right there. And the domain range is easy for the cube root. It's both from -infinity to +infinity, both domaining range. And then the x-intercept. We're not going to spend a lot of time doing this, so don't really worry about this too much. You can just go nothing. But if you were to plug it in, you know that y is 0 right there, and then you just solve for x, but don't get too worked up on that. And then the y-intercept, it's easy. You can just pull that out from the graph. So 0, -4. Okay, so here is what's new, and it's not awful. So we need to write the function for this graph. It's either square root or cube root. And in this case, it's going to be square root. That's why I put the radical right there. Something else we need to get is where it starts. So it starts off right there at -3, 1. So your h and k are -3, 1. That's where it starts. And then you also need to choose another point, which is going to be x and y. I just chose that one just because it's a whole number and it's easy to pick. So -2, 3. And then I went there and I substituted that on the function because I need to find the stretch or compression from the vertical. I need to find a right there. Okay, so I have y is 3. Y is 3a, that's what I'm looking for. X is -2. H is -3 because the formula calls for minus h. That's why two negatives make a positive. That's why I ended up with a +3 right there. And then plus k. All right, so I'm going to solve for a. -1 on both sides, I got 2. Square root of 1 is 1, so 2 divided by 1 is 2. So here, my a is 2. Now I'm just going to check. All this work right here, all I did was to check, make sure that I didn't do anything crazy. So if my y is 3, my a is 2, if I plug in h, k, and x, would that check off? Yes, it will. So 3 equals 3. That works out. Therefore, the function for this graph right here, the function that represents this graph will be 2 square root of x plus 3 plus 1. Same thing we're going to do here. So now I have the cube root. I know that's the parent function because it does the little wee right there. So I know it's cube root. And right there, where it should have been 0, 0, it's not. It's right there, left, or -4, -2. So it went left, 4, down 2, and it also reflected across the x. So no matter what, I know there's going to be a negative there. Okay? All right. So, and then I chose another point for x and y right there. -5 is x, -1 is y. So, and that's what I plugged in here. -1 for y. I know a is going to be negative. And then I have x is going to be -5. It went left 4, so +4. And then -2 because it went down 2. Okay, so add 2 to both sides. I get 1 right there. This is -1. Cube root of -1 is -1. 2 negatives make a positive, so a equals 1. Perfect. And then just make sure, even though you know you did it right, just go 30 more seconds to plug it in and make sure that you didn't forget a negative, you didn't forget to square something. Just do it. And the last one, I have, again, another cube root. And the only thing that happened here went just 5 up. Okay? So, and then I need to choose another point, and I chose that point right there. It's going to be 8, 8. So that was easy. So 8 for y, 8 for x. And I don't see any reflection of any kind right there. So a will be positive. So substitute 8 for x, 8 for y, and 5 for k. And that's what I did there. So -5 on both sides, I get 3 there. Cube root of 8 is 2. Divide both sides by 2. So a is 3/2. Just make sure you go that extra 30 seconds to check your work, make sure that that checks out. And then your final answer is the function that represents this graph right here. The end.